Hello Algebra 1, this is the first of a two-part video lesson about Chapter 3.5, which gives you some different techniques for how to solve word problems. Word problems often pose a challenge for kids in Algebra 1 and in Algebra 2. The first technique they talk about is drawing a diagram, or drawing a picture. And we talked about this in class. For those of you who were in class, you're going to remember this Do Now assignment that I gave you, which was about a house that had 3 windows along the back side of it. If you weren't in class or don't remember the problem, go ahead and hit the pause button, read this paragraph, and remind yourself what the question was. Okay, I'm going to assume that you did that. And after all, this is a lesson in how pictures can help with solving word problems. So in this first problem, I gave you the picture straight out of the textbook, and they were particularly nice when they wrote this picture or drew this picture for you, because they wrote all of the numbers and all the variables that you needed to solve the problem, and in their proper places. So just like this says, there are 4 feet on the left edge and the right edge of the house. So there's 4 and another 4. Just like it says here, the windows are 3 feet wide. There they are, 3 feet wide. And there are 3 of those windows, 1, 2, 3, so that's all filled in. And the question you were asked is, how far apart should the windows be? Well, often when we are trying to ask a question in algebra and we don't know what a number should be, we put in x for that number. So that's how far apart those windows should be. So as we said also in class, the way to solve this is simply to write this string of numbers and variables, constants and variables, and set that equal to the answer that you're given. You're told that the width of the house is 33 feet. Well, there it is, 33, and this string put together. So you should know to pull the like terms together, the constants, the ones in black there, and the variables, the ones I've indicated in red, separately. So you should end up with 17 plus 2x is equal to 33. And from here you should be able to solve this question, because this looks a lot like the questions that were on our most recent quiz. And you would find, if you did, that x equals 8. So if you didn't get 8, aren't sure how to calculate 8, or have any questions about this, don't hesitate to come in and ask me about this, because from now on I'm going to assume, since we've already had this quiz, that you know how to solve questions like 17 plus 2x equals 33. And the real lesson here today is more in how to read a word problem, make use of a drawing if they give it to you, or draw your own drawing if they don't, and go from there to get this equation like 17 plus 2x equals 33. So, speaking of that, here is another word problem, and this time it doesn't have a drawing. I know that I gave you something similar to this in class if you were in class, but even if you were, this is going to be new to you because I've changed the numbers around. So everybody at this point should hit the pause button, read this paragraph, and go ahead and answer the question, which is, how far apart should the windows be? When you come back, I'll show you the answer. Okay, I'm going to assume that you did that. And I've made this drawing, and as I've shown, the building is 60 feet wide. And I've pulled all these variables and constants together down here and made this expression on the left and set it equal to 60. And from here, you should be able to solve for x, and you should find that x equals 2 once again. If this isn't the answer you got, or you have any questions about this, don't hesitate to come in and ask. But I'm not going to continue to show how to go from this stage to solving it and saying that x equals 2. I'm going to assume that you know how to do that from now on, unless you ask me about it. Instead, I'm going to move on to the next problem that we talked about. This is actually the first example from the textbook, but I gave you the question about the windows in the house first because I thought that was a better place to start. This is just a slightly more complicated version of the same sort of question. If you haven't read this before, and you should have because it's straight out of the textbook, hit the pause button now. Otherwise, I'm going to go ahead and show you that the textbook also provides you with a picture in this case. And they not only do that, but they very nicely identify all the measurements that go with the picture. So in black are all the constants, in red are the variables, W for the width of each of the different boxes for each of the different pictures that's supposed to go into the yearbook. So from here, we talked in class about the idea that you could leave all of this information in fraction form if you wanted to, and that's what I've done here. On the left, this expression in black and red is simply this, with all of the w's pulled together as 3w, and I've set it as an equation equal to 8.5. We talked in class about the idea that the textbook is kind of misleading because it talks about the height of the page as well as the width of the page. We only care about the width of the page in this case. We also talked in class about the idea that you don't really need to leave these in fraction form if you don't want to. If you prefer decimal form, that's fine too. 3/4 becomes 0.75. In this case here, I've pulled both of these 3/16 measurements together, and I've said it's 2 times, well, converting 3/16 to a decimal, it's 0.1875. Either way, whichever of these two ways that you set this up, you should end up with the same answer that the textbook does, which is 1.5 inches wide for each photograph, solving for W. And notice the textbook also, from now on, just goes straight from equation to saying, when you solve for W, you will find. Because the textbook and I, from now on, are going to assume that you can solve equations like this and find W. If you're still having trouble with them, don't hesitate to come in and ask me about it, please. Here's a similar question. Again, this is different than any that you've seen in class, so everybody should be planning to solve this. Go ahead and hit the pause button. When you come back, I'm going to show you the answer to this one. Okay, I'm going to assume that you've paused, you've worked this through, you've drawn the pictures that you needed, and you came up with an answer. Here's the basic frame of the picture that I drew. 4 different spaces for 4 different photographs, and a left margin that's narrower and a right margin that's wider because it's 1.5 inches on the left and 2 inches on the right. And there all the numbers are filled in. Once again, I've crossed out the 12. That's misleading. I really only care about the fact that the page is 9 inches wide. And I've indicated here that the page is 9 inches wide. Now I've pulled all of the constants and all the variables down here. I've put all of the variables, all of the w's together and made it 4w. And from here you should be able to solve this and tell me what w is, and w turns out to be 1. So don't hesitate to come in and ask if you don't get one or don't understand it or don't have any questions about it. But otherwise we're going to move on to the next lesson that came out of today's class discussion, and also the next lesson that comes out of the textbook. Because sometimes pictures don't fully fill the need, and sometimes you'd rather actually have your information organized in a table. Here's the question we talked about in class as our example of the case where we'd like to have a table. I said in class, I don't really want to draw a picture with 579 students in it. There has to be a better way. And the textbook offers this table for this first example here, or example 2, the first of the table examples. And what they say here is in year 0, which is now, there are 579 students taking Spanish, 217 taking French, and I've been asked to multiply the number taking French by 3 to get 651. Why? Because the question was, when will there be 3 times as many students taking Spanish as there are taking French? Well, I've got to triple the number of French and see if these two numbers match, and they don't. So I run the machine, the clock, 1 year farther ahead. I add 30 to the number taking Spanish. I subtract 2 from the number taking French. I multiply this number, now 215 times 3, and 645 still does not match 609. So I run the clock another year forward. And now I I add another 30 here, so I've got 639. I subtract 2 from here, I get 213. But this time when I multiply that by 3, I get 639 again, the same number as here. So this year, year 2, is the year when there are 3 times as many students taking Spanish as taking French. So the answer is year 2. Here is a similar question, but it's actually not quite as complicated because the one I just gave you forced you to triple the number of students. But But it is another case where I'm going to ask you to create a table. It's different than anything you've seen in class so far, but I want you to go ahead and create a table from this information and come back to me with the answer to the question, which is, in how many years will the CD player sales be the same as the cassette player sales? So go ahead, hit the pause button, and when you come back, I'm going to work through the answer to this question with you. Okay, I'm going to assume that you did that. Here's the frame of the table that I've built here. Again, year 0 is now, and I've allowed room for 4 years here. My first row is for cassettes, my second row is for CDs. In year 0, there are 640 cassette players and 200 CD players. The next year, I subtract 70 from the cassettes, add 40 for the CDs, still no match. So I subtract another 70 here, I add another 40 there, still no match in year 2. Year 3 still doesn't match, but in year 4, they do match. So the answer to the question is, in year 4, you will have, as asked here, the same number of CD players as cassette player sales. So that's it. That's that part of the chapter, and that's it for this video lesson. As I said, I'm going to have a separate, shorter one for the rest of the lesson.